Hello and welcome to another lecture on time complexity. In today's session, I will explore polynomial time complexity using a practical example. I believe learning through examples is often the most effective approach, so let's jump in and break down how polynomial time complexity works. In this piece of code, we are going to look at the nested loop, which is a common example of code that runs in polynomial time. This piece of code takes a 2D list like a list of lists and adds 3 to each number inside the lists. Here, as is observed, we have a nested loop. The outer loop iterates through each sublist items. Therefore, if we have n sublists, the outer loop runs n times. For the inner loop, it iterates over each element in the sublist. In this case, we have 3 elements per sublist. If each sublist has m elements, the loop runs m times for each sublist. And finally, 3 will be added to each element. Please keep it in mind that we have 2 nested loops, therefore the total number of operations grows with the product of the 2 loops. As you can see, the outer loop goes through each sublist first, and then the inner loop adds 3 to each element. This procedure is highly dependent on the number of sublists and the number of elements within each sublist. So the time complexity of this code is big O of n times m, where n is the number of sublists and m is the number of elements in each sublist. The number of sublists is roughly equal to the number of elements in each sublist. Therefore, the time complexity is big O of n to the power of 2. One common example for polynomial time complexity is quadratic time, where the time required grows with the square of the input size. Here, the number of operations increases quadratically as the input size increases. This is often seen in algorithms with nested loops, where for each element in the outer loop, the inner loop runs over the entire set of elements. As you can see, the number of operations increases rapidly as n grows. For example, going from an input size of 1 to 10 causes the number of operations to grow from 1 to 100. I tried to convey the intuition behind polynomial time complexity, and I hope you found it helpful. Thank you for watching this video. Feel free to share your thoughts and feedback.